What is a Pascal's triangle? It is a triangular arrangement of numbers where the top starts with 1 and each number is a sum of two numbers directly above it. And this triangle can go about to infinity. Now, how to draw this Pascal triangle? In each row, we will always have 1 at start and 1 at end. This is clear. Now, for the remaining terms, as we earlier said, we are going to add the above two number digits. We said over here, no? Each number is the sum of two numbers directly above it. So now, for this number, we are going to add these two numbers, okay, which is 1 plus 1 is equal to 2. Now, above this position, there is 1 plus 2, which is again 3. Now, for this term, we are going to add the numbers above it, which were 2 and 1 again. And continuing this, we will get this triangle, which is known as Pascal's triangle. How it is connected with binomial theorem. To solve this expression, we use binomial theorem, and each coefficient can directly be derived from this Pascal's triangle. How? The number in row n of the Pascal triangle gives the coefficients. As over here, for example, a plus b's power 4. Over here, n is 4. We can get the coefficient of this expression from the fourth row. N is equal to 4. Then we are going to use row number 4. Okay. So, for row number 4, we have 1, 4, 6, 4, 1. So, the coefficient of this expression will be 1, 4, 6, 4, 1. Now, other terms are a to the power 4 and b to the power 0 into b to the power 0. Then, second term will be a raised to the power 4 minus 1, which is 3, and b to the power 1 again. Third term will be this first term. We are going to decrease this power of a and going to increase the power of b. So it will become a to the power b, sorry, a to the power 2, b to the power 2, and a raised to the power 1, b raised to the power 3, and last term will be right over here 1, a raised to the power 0, b raised to the power 4, which is the same as this. So we got the coefficient of this binomial expression a raised to the power b, a plus b power 4 as 1, 4, 6, 4, 1 from row 4th of the Pascal's triangle. Are some properties of this Pascal's triangle that numbers are symmetric about the center and each row adds up to be a power of 2. Now, if I add these numbers, I will get 1, which is 2 is power 0. And if I add second row, I will get 2 is power 1. If I add this second row, I will get 2 raised to power 2. If I add this third row, 3 plus 1, 4, 4 plus 4, 8, which is 2 to the power 3. Similarly, this power is equal to the number of rows. I will get 2 to the power 4, 2 raised to power 5, 2 raised to power 6. If I add all these terms of this row, and at last, this combination gives us each entry for NCR, which was the coefficient of the terms in binomial expression, n factorial upon r factorial into n minus r factorial. Either we are going to use this formula or we will get this entry from this Pascal triangle directly. So hope you like this video.